Hello, everyone, and welcome. I'm excited to be here today to talk about the Grit Removal Equipment Troubleshooting Guide. This presentation is all about helping you identify and resolve common issues in grit removal systems. The title, as you see, is Grit Removal Equipment Troubleshooting Guide, and it's designed to be a comprehensive resource. We'll walk through systematic approaches to diagnosing problems, monitoring key parameters, and implementing effective solutions to keep your grit removal systems running smoothly. Although this is just the first slide, I promise we'll cover practical tips based on US EPA guidelines from 1978. So let's get started and explore how to maintain optimal grit removal efficiency in wastewater treatment facilities. Let's take a closer look at understanding grit removal systems. So, what exactly is grit? Grit refers to those heavy inorganic particles like sand, gravel, cinders, and other dense materials that often find their way into wastewater treatment plants. These particles are quite heavy compared to organic matter, which means they tend to settle quickly if not properly managed. Now, why is it so important to remove grit? Well, first, it helps prevent excessive wear and tear on pumps and other equipment. When grit gets into machinery, it can cause damage and reduce their lifespan. Additionally, removing grit reduces buildup in tanks and channels, keeping the system flowing smoothly. It also protects the downstream treatment processes, because if grit isn't removed early, it can cause blockages or damage further along the treatment line. Lastly, by controlling grit, we minimize maintenance costs and reduce downtime, making the entire operation more efficient and cost-effective. So, understanding and properly managing grit is a key part of ensuring our wastewater treatment systems run reliably and effectively. When it comes to common grit removal equipment types, there are a few key options to consider. First, we have aerated grit chambers. These use air diffusers to create a spiral flow pattern, which helps separate grit from organic materials. The controlled turbulence and settling process makes sure that grit settles out effectively while organic matter stays suspended. Next, we have cyclone degritters. These devices rely on centrifugal force to separate grit from water and organic matter. They operate at specific pressure ranges to optimize performance, ensuring that grit is efficiently removed without disrupting the flow. Finally, mechanical collectors come into play. They use chains, flights, or bucket elevators to physically remove the settled grit from the bottoms of the chambers. This equipment then transports the grit for disposal, making the process more automated and efficient. All of these types are essential tools in our overall approach to effective grit removal, helping us maintain cleaner water and improve downstream treatment processes. Let's talk about the first common problem we encounter: grit packed on collectors. This issue shows up as excessive accumulation of grit material on the mechanical collection equipment. When this happens, it can really hinder operational efficiency and even cause damage to the equipment itself. Now, what causes this? One major factor is that the collector might be operating at too high a speed. When the collector runs too fast, it doesn't give enough time for the grit to be properly transported or removed, leading to buildup. Conversely, if the bucket elevator or grit removal systems are running too slowly, the grit can pile up as well. So the key here is to check the collector speed. We want to monitor and ensure that the collector's operational speed stays within the recommended parameters. Similarly, we need to verify that the speed of the removal system, like the bucket elevator, is adequate for transporting the grit effectively. And what can we do to solve this? If we find the collector is going too fast, reducing its speed can help prevent packing. Alternatively, if the grit removal system isn't keeping up, increasing its speed will facilitate better removal and prevent buildup. Overall, maintaining the right balance in speeds is crucial to keeping the system running smoothly and avoiding the problems caused by packed grit. Let's talk about the second major problem we often see with cyclone degritters: vibration. Vibration in these systems is a serious operational concern because it can signal flow obstructions or imbalances that, if left unchecked, might lead to equipment damage or reduced separation efficiency. So, addressing this quickly is crucial for smooth operation. First, one common cause is an obstruction in the lower port. When you notice vibration, it's important to check the flow coming from the lower discharge port. Look for any blockages or restricted flow patterns that might be causing the system to be unbalanced. If you do find an obstruction, the solution is straightforward. Remove it to restore proper flow. The second potential cause is an obstruction in the upper port. This often manifests as excessive flow accumulation at the lower end of the cyclone. To fix this, you should consider reducing the inlet flow rate. Doing so helps to balance the system and eliminate the vibration. By understanding these two key points, checking both the lower and upper ports, you can quickly identify and resolve vibration issues, helping to maintain the cyclone's efficiency and prevent damage. Remember, addressing vibration isn't just about fixing a noise, it's about ensuring the overall health and performance of the system. Let's talk about problem 3, which is the rotten egg odor issue we're facing in the grit chamber. This distinctive smell actually points to the formation of hydrogen sulfide, or H2S, which is a toxic and corrosive gas. It tends to form under anaerobic conditions, meaning in environments without oxygen. Not only is this a safety concern for our team, but it also signals that there might be operational issues we need to address. Now, to diagnose this problem, there are a few key steps. First, we should take a sample to check for sludge deposits in the chamber, since these deposits can harbor bacteria that produce hydrogen sulfide. Next, testing for total sulfides in the wastewater helps us understand how much of this compound is present. Measuring the dissolved sulfides concentration gives us a more precise idea of the severity of the problem. And finally, assessing whether our ventilation is adequate is crucial. Proper airflow can help reduce the buildup of these gases. As for corrective actions, a thorough cleaning of the chamber is essential, removing all sludge deposits. After cleaning, dousing the chamber with hypochlorite, or bleach, helps oxidize the sulfides and eliminate the bacteria responsible for the odor. These steps not only address the immediate odor problem, but also help prevent its recurrence, supporting the overall goal of maintaining a safe and efficient operation. Let's talk about problem 4, accumulated grit in the chamber. One common cause of this issue is submerged debris. If debris gets stuck in the chamber, it can lead to buildup over time. To prevent this, it's crucial to inspect the chamber thoroughly for any debris accumulation regularly. A good practice is to wash the chamber daily and remove all debris to keep things clean and prevent buildup. Another cause to watch out for is low flow velocity. When the flow isn't strong enough, grit doesn't get transported properly and can settle out. So, it's important to verify that the flow velocity is adequate for moving grit along. If it's too slow, you might need to adjust the flow controls to maintain the proper velocity for effective grit transport. Finally, equipment failure can also contribute to grit accumulation. This includes issues with chains, flights, or other mechanical components that might be broken or worn out. Regularly inspecting these parts is key. If you find any broken equipment, repair or replace it immediately to keep the system running smoothly and prevent grit buildup. Overall, addressing these causes systematically helps us keep the chamber clean and functioning efficiently, which is essential for the overall success of the system. Let's talk about problem 5, corrosion of metal and concrete. Corrosion in grit chambers mainly happens because hydrogen sulfide gas, or H2S, attacks the surfaces of metal and concrete. When the ventilation isn't adequate, this gas can build up, creating really corrosive conditions that can cause serious damage to the infrastructure. To manage this, we need a solid monitoring protocol. That includes assessing how well the ventilation system is performing, regularly sampling for sludge deposits, testing for total sulfides in the system, and measuring the concentration of dissolved sulfides. All these steps help us understand the extent of corrosion risk and catch problems early. Prevention is key. Increasing ventilation helps remove these harmful gases, reducing the corrosive environment. Additionally, performing annual repairs and repainting of affected surfaces acts as a protective measure, prolonging the lifespan of our infrastructure. By understanding these points and implementing proper monitoring and prevention strategies, we can effectively combat corrosion and maintain the integrity of our systems. Let's take a closer look at problem 6, poor grit quality. When we notice that the removed grit appears gray, smells bad, or feels greasy, it's a clear sign that organic material isn't being separated effectively. This contamination not only decreases the quality of the grit we collect, but also points to potential issues in our separation process. To address this, we need to start by checking the cyclone pressure. It's important to monitor the discharge pressure on the cyclone degritter and keep it between 28 and 41 kPa, or 4 to 6 psi. We can do this by adjusting the pump speed and following the lubrication guidelines outlined in our operations and maintenance manual. Next, verifying the airflow rate in the aerated grit chambers is crucial. Proper aeration is essential for effective separation of organics from the grit. If we find the airflow insufficient, we should increase it to improve the process. Lastly, assessing the velocity within the grit removal system helps ensure everything is functioning correctly. One practical way is to use dye or floating objects to check the velocity. If it's too low, we need to increase it in the grit chamber to enhance separation efficiency. By focusing on these key points, pressure, airflow, and velocity, we can significantly improve grit quality and overall operational performance. Let's talk about problem 7, reduced surface turbulence. Now, turbulence plays a critical role in aerated grit chambers. It helps ensure proper grit separation by creating a spiral flow pattern through the air diffusers. This pattern keeps lighter organic materials in suspension while allowing the heavier grit particles to settle out. When we see reduced turbulence, it's often a sign that something's not functioning correctly in the system. A common cause is that the diffusers might be covered by rags or accumulated grit, which blocks the air release. This blockage prevents the turbulence from forming properly, leading to poor grit separation. So the first step is to check all the diffusers for any blockages or debris coverage. If you find any, they need to be thoroughly cleaned. Additionally, it's important to revisit upstream screens or pretreatment steps to ensure they aren't contributing to the buildup and to prevent this problem from recurring. Maintaining proper turbulence is essential for the effectiveness of grit removal, and catching these issues early keeps the entire process running smoothly. Let's talk about problem 8, uneven surface turbulence. First, we need to observe the pattern. What we're looking for is areas where surface turbulence is higher in some spots, but noticeably lower in others. This creates an uneven flow, which can affect the overall system performance. Recognizing these irregularities is key to understanding the root cause and ensuring proper airflow throughout the chamber. Next, we want to identify the cause. Often, uneven turbulence stems from broken diffusers or headers. These damaged components disrupt the air distribution, leading to those inconsistent flow patterns we see. It's important to pinpoint exactly where the issues are occurring to effectively address them. Then, we need to inspect the system thoroughly. This means checking all diffusers and headers carefully for cracks, breaks, or disconnections. Sometimes, damage can be subtle, so a detailed visual inspection is essential to catch all potential problem areas. Finally, once we've identified any damaged parts, we move on to implementing repairs. This involves repairing or replacing the broken diffusers or headers to restore a uniform turbulence pattern. Restoring even airflow is critical, not just for system efficiency, but also for maintaining the quality of the process we're working with. By systematically observing, identifying, inspecting, and repairing, we can resolve uneven surface turbulence and keep our system running smoothly and effectively. Let's take a closer look at problem 9, low grit recovery rate. Understanding recovery efficiency is crucial because when grit isn't properly removed, it can slip through the system and enter downstream treatment processes. This can lead to equipment wear, accumulation issues, and ultimately reduce the overall treatment efficiency. Addressing this problem quickly is essential to protect the entire treatment plant. One key factor we need to monitor is the bottom scour speed. Specifically, we should check the velocity within the grit chamber. If the velocity is too high, grit won't settle properly and could be carried away. The goal is to maintain that velocity near 0.3 meters per second, or about 1 foot per second, to ensure proper grit settling. Another aspect to watch out for is excessive aeration. We need to assess both the rate and intensity of aeration happening in the system. If aeration is too high, it can disturb the grit settling process. The solution here is to reduce the aeration and increase the retention time, either by adding more grit removal units or reducing the flow to the existing units. By controlling these factors, monitoring velocity and managing aeration, we can significantly improve grit recovery and enhance the overall efficiency of our treatment process. Now let's discuss problem 10, overflowing grit chamber. An overflowing grit chamber is a serious operational emergency. It can lead to environmental violations, pose safety hazards, and cause damage to surrounding equipment and structures. That's why immediate action is crucial to identify and fix the root cause. One common issue is pump surge, so we need to check the pump operation closely. Look for signs of surging, cycling, or irregular flow patterns, as these can cause sudden rises in the water level within the grit chamber. The solution here is to adjust the pump controls to eliminate surging. Our goal is to ensure a steady, consistent flow into the grit chamber, which helps prevent overflow. Another factor to consider is excessive influent flow. We need to monitor the influent flow rate carefully. If it exceeds the system's designed capacity, it can overwhelm the grit removal process. To address this, we should work on controlling inflow and infiltration, what we often call I and I in the collection system. Reducing peak flows entering the treatment plant helps maintain proper operation and prevents the grit chamber from overflowing. Remember, tackling these issues promptly keeps our system running smoothly, protects the environment, and ensures safety for everyone involved. Let's talk about problem 11, septic conditions in the basin. Recognizing septic waste is crucial. When you notice grease and gas bubbles rising in the basin, that's a clear sign that anaerobic decomposition is happening. This process produces foul odors and corrosive gases, which can cause operational problems throughout the entire treatment plant. Now, let's look at the root cause. Sludge builds up at the bottom of the basin, creating anaerobic zones. In these zones, bacteria produce gases like hydrogen sulfide and methane. At the same time, grease and organic materials float to the surface, attaching to gas bubbles. To prevent these issues, regular maintenance is essential. You should check the bottom of the grit basin regularly for sludge deposits. And the solution is to wash the basin daily. This helps prevent sludge buildup and keeps conditions aerobic, ensuring the system runs smoothly. So, by staying vigilant and maintaining the basin properly, we can avoid these septic problems and keep the treatment process efficient. Let's take a closer look at problem 12, decreased grit pump efficiency. When a pump isn't working as well as it should, you'll notice some key symptoms. These include a reduced flow rate, meaning less material is being moved. You might also see increased power consumption, which indicates the pump is working harder than it should. Unusual noises or vibrations are also common signs that something's off. To diagnose the issue, we need to consider common causes. Worn seals are a frequent culprit, as they can lead to leaks and decreased efficiency. Shaft components may also wear out over time, and damage to the impeller, like erosion or cracks, can severely impact performance. It's important to remember that grit is highly abrasive, and this accelerates wear on these parts. When inspecting the components, start by checking the seals for any leaks. Next, examine the shaft for signs of wear or scoring, which can indicate excessive friction or damage. Also, inspect the impeller carefully for erosion or any physical damage. Once you've identified the problem, implementing repairs is crucial. This often involves replacing worn seals to prevent leaks. Lubricating the pump according to the specifications in the operations and maintenance manual helps reduce further wear. And don't forget to inspect the impeller thoroughly. Replace it if necessary to restore proper flow and efficiency. Addressing these issues promptly not only improves pump performance, but also helps prevent more serious damage down the line, keeping your entire system running smoothly. Let's discuss problem 13, which is decreased cyclone efficiency. When we notice that grit removal through the cyclone degritter isn't working as well as it should, it suggests that the centrifugal separation process isn't functioning optimally. This can lead to grit slipping through the system and contaminating downstream processes, which we definitely want to avoid. The main diagnostic indicator here is a decrease in grit removal efficiency via the cyclone degritter system. A common probable cause for this is that the inlet pressure is too low to generate the necessary centrifugal force needed for effective grit separation. So, as part of our check, we should monitor the inlet pressure to the cyclone degritter and compare it against the design specifications. If the pressure is below the recommended range, that's likely the root of the problem. To correct this, we need to increase the inlet pressure. This can be done by adjusting the grit pump discharge. The optimal pressure range for cyclone degritters is typically between 28 and 41 kilopascals, or roughly 4 to 6 pounds per square inch. Maintaining pressure within this range ensures that we produce enough centrifugal force for the system to work effectively, and that means better grit removal and cleaner downstream processes. Let's take a closer look at some key operating parameters that ensure our system runs smoothly. First, maintaining an optimal velocity of about 0.3 meters per second, or roughly 1 foot per second, in the grit chambers is crucial. This helps us achieve proper settling of particles without disturbing the process. Next, when it comes to cyclone pressure, we want to keep it between 28 and 41 kilopascals, which is about 4 to 6 pounds per square inch. Staying within this range ensures the cyclone operates at peak efficiency, effectively separating grit from the water. Now, regarding cleaning routines, it's important to wash the grit chambers daily. Regular cleaning prevents the buildup of sludge and helps avoid septic conditions, which could compromise the system's performance and safety. Finally, don't forget about maintenance. An annual cycle of repairs and repainting is essential. This helps prevent corrosion and extends the lifespan of the equipment, keeping everything in top shape year after year. All these parameters are interconnected and vital for the overall health and efficiency of our operation, supporting the broader goal of effective and sustainable water treatment. Let's dive into some best practices for preventive maintenance that can really make a difference in our operations. First, daily inspections are crucial. I like to think of this as our routine health check. We need to visually inspect grit chambers, look for any unusual odors, and observe how the surface turbulence patterns behave. Also, don't forget to wash the chambers regularly to prevent sludge buildup, which can hamper performance. Monitoring the quality and amount of grit removed each day helps us catch issues early. Moving on to weekly monitoring, this is where we get a bit more technical. Testing flow velocities is important, and using dye or floating objects can give us a clear picture of flow efficiency. We should verify our pump performance and pressures to ensure everything's running smoothly. It's also essential to inspect our mechanical collectors for wear and tear and check the diffusers in aerated chambers. These are key to maintaining optimal aeration. Monthly maintenance takes a deeper dive. Lubricating pumps and mechanical parts according to the manufacturer's specifications helps prevent unexpected breakdowns. We should also inspect and clean diffusers and headers to keep airflow consistent. If we're noticing any odors, testing for sulfides is a good idea, as they can indicate issues with our treatment process. Finally, reviewing operational data trends allows us to spot patterns and plan better for future maintenance. And then there's the annual overhaul, which is our comprehensive checkup. This involves inspecting all equipment thoroughly, replacing worn components before they fail, and repairing any surfaces that have corroded. Repainting helps protect against further corrosion, and updating our operation and maintenance procedures based on what we've learned keeps us ahead of potential problems. By following these best practices consistently, we not only extend the lifespan of our equipment, but also ensure our treatment processes remain efficient and reliable. It all ties back to our overall goal of maintaining a smooth, effective operation. Let's walk through the troubleshooting decision tree, which is a vital part of maintaining smooth operations. First, observe and document what's happening around you. Look for specific indicators like unusual odors, visual changes in equipment or products, strange sounds from machinery, or any performance metrics that seem off from normal. Noticing these details helps us pinpoint where the problem might be. Next, check the key parameters. This means monitoring the relevant operational data, things like flow rates, velocities, pressures, equipment speeds, and chemical conditions. These parameters can give us clues about what's going wrong, especially when they deviate from expected ranges. Then, identify the probable cause. Using the data you've gathered along with your operational knowledge, you can determine the most likely source of the issue. It's about connecting the dots. What might be causing the symptoms you're observing? Once you've identified the cause, implement the solution. This could involve applying corrective actions, adjusting operational settings, repairing or replacing equipment, or modifying procedures to fix the problem effectively. Finally, verify that the problem is resolved. Continue monitoring system performance after your actions to ensure everything is back to normal. And don't forget to document what you did. This helps build a record for future troubleshooting and continuous improvement. This decision tree approach ties into our overall theme of proactive, systematic problem solving. It ensures we don't just react to issues, but understand and address their root causes efficiently. Maintaining optimal grit removal performance is really the foundation of a successful wastewater treatment plant. When we talk about effective grit removal, we're talking about setting the stage for everything that follows. By systematically troubleshooting problems using this guide, you can keep your system running smoothly, protect your downstream equipment, and stay in compliance with regulations. One of the key takeaways is that regular monitoring is crucial. Catching small issues early prevents them from turning into major failures down the line. Understanding cause and effect relationships within your system allows for quick diagnosis, so you're not wasting time guessing what's wrong. Preventive maintenance is also more cost-effective than reactive repairs. It saves money and reduces downtime. Additionally, documenting problems and their solutions helps build institutional knowledge, so future operators can learn from past experiences and avoid repeating mistakes. Remember, this troubleshooting chart should be a living document. Continuously update it with your plant-specific experiences, add new problems and solutions as they come up, and ensure all operators are trained in this systematic approach. Excellence in grit removal isn't just about this one step. It protects your entire treatment process. When you keep these principles in mind, you're setting the foundation for overall success in your plant operations.